In this video, we're going to take a look at a technique that can help us better conceptualize what's happening when we multiply fractions. So let's take, for example, 2/3 times 3/4. Now, your teacher may have already showed you the shortcut to this, and the shortcut to multiplying fractions works very well, and it's very easy. The shortcut simply says multiply the numerators times each other. So we multiply 2 times 3, that equals 6. And then we multiply the denominators together, 3 times 4 equals 12. So 2/3 times 3/4 equals 6/12. Or we could say 2/3 of 3/4 equals 6/12. And when we look at 6/12, we recognize that that can be simplified because 6 is half of 12, so that would simplify down to 1/2. Okay? And although the shortcut is very effective and very efficient, it doesn't really help us visualize what's happening when we're multiplying fractions. So a way to visualize that is a technique that you probably used and learned about when you were learning your basic facts, and that is the technique of an array. An array is a visual way to see what's happening when you multiply two whole numbers together. It can help you better understand how you get to the answer that you get to as you're in the process of learning your basic facts. So let's say, for example, I've got these numbers up here, so I'll go ahead and use them. Let's say we're going to make a 3x4 array. So I've got the grid paper over here, so I'm going to draw 1, 2, 3, 1, 2, 3, 4. I'm going to make a 3x4 array. So this is 3x4. I have 3 columns going down, and I have 4 rows going across. So I have a 3x4 array, and if we went through and counted up all the equal parts on the inside, all the squares on the inside, we would end up with 12, which is what 3 times 4 is equal to. So as we learn about arrays, we learn to figure out the shortcut. Rather than counting all of the inside squares, we can just say 3 times 4 equals 12. Okay, so how can we apply this to fractions? So let's go back to our original problem. We had 2/3 times 3/4. Now, if we're going to draw an array to represent 2/3 times 3/4, we first have to make sure that we understand something about fractions. The denominator represents the whole amount, and the numerator represents the part of the whole that we're talking about. So when we look at, for example, 2/3, what we mean is that there are 3 whole parts, but we're only interested in 2 of those 3 parts. And when we look at 3/4, there are 4 equal parts in total, but we're only interested in 3 of them. So when we go to draw our array, the first thing we have to do is draw the entire array that represents all of it, which would be a 3x4 array. So let's draw that. 1, 2, 3. 1, 2, 3, 4. So here is my 3x4 array. But I'm not actually interested in all 3 columns, and I'm not interested in all 4 rows. I'm only interested in 2 of those 3 columns and 3 of those 4 rows. So what I'm going to do is I'm going to draw a diagonal through the 2 columns that we're interested in, and I'm going to draw another diagonal through the 3 rows that we're interested in. Okay. So what ends up happening is I have some of the equal parts, some of the squares that have X's in them, some that just have hash marks, and then there's one that has nothing in it. What I'm interested in is the parts where they intersect. In other words, the parts that have the X's in them. These squares here represent 2/3 of 3/4. This is the fractional part of the array that I'm interested in. So now all I have to do is count up these squares, and there's 1, 2, 3, 4, 5, 6 squares, and my denominator is going to be the total amount of squares, which I know this was a 3 by 4 array, so it was 12. So 6 of the 12 squares are the fractional part that we're talking about when we're talking about 2/3 times 3/4, or 2/3 of 3/4. And of course, like I said before, we know this simplifies down to 1/2. Okay, let's try one more. All right, let's take the fraction 3/5 and let's multiply it times 4/7. So again, to create my array, the first thing I'm going to do is look at the denominators of these two fractions to see what the entire array should be. This is 5 parts total, and this is 7 parts total. So this is going to be a 5 by 7 array. So let's draw that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So I'm going to draw my array, box it in. And this is going to be 5 columns and 7 rows, but I'm only interested in 3 of those columns, and I'm only interested in 4 of the rows. So let's draw those in and make my diagonals. I'm interested in these 3 columns, and I'm interested in these 4 rows. Okay, I'll make sure I get all of them drawn in, and I can see right away that I have some X's, and then I have some blue diagonals that are by themselves, some red diagonals by themselves, and then some squares that have nothing in them. So there's actually quite a bit that I can learn from this array, but what I'm focused on right now is the part where they intersect. This is the fractional part of the array that I'm interested in right here. So this represents 3/5 of 4/7. So let's count them up. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 fractional parts. And then I go and look at the entire array. This was a 5 by 7 array, and 5 times 7 is 35. So out of the total 35 equal parts, I'm only interested in 12 of them. So when I multiply 3/5 times 4/7, I get 12 35ths. This is a great way to get a better understanding of what's taking place when we multiply fractions.